Okay, let's look at the compound interest. All right, let's first go over notation. All right, P denotes the principal. All right, principal is basically the same thing as present value. Or initial investment. Right, so that's the amount of money you deposit in the beginning. All right, R denotes the annual interest rate. This is written in decimal, so in decimal. All right, for example, if the interest rate is 3%, then R value is 0.03 because 3% is 3 over 100. All right, M denotes the number of compounding periods per year. So if it's say monthly, then M is going to be, so monthly, so there's a 12 months, 12 times per year, so M is going to be 12. Right? If it's say quarterly, then M is going to be 4. So it's every 3 months. Right? And so on. Right? T is just the time in years, so that's T. And A is amount after T years. And sometimes you can write it as a function of T, so you can write it as A of T if you want. All right. All right, let's look at a couple of interest formulas. All right, so first one is compound interest formula. I'm pretty sure you have seen this. So future value or amount after T years A is going to be equal to principal times quantity 1 plus annual interest rate divided by the number of compounding periods per year raised to the MT, right? And sometimes we use the notation P times quantity 1 plus I, right, instead of R or over M, and N instead of MT. So we have to, so this is going to be where, right? I is simply the interest rate per period, which just means that take the annual rate divide by the number of compounding periods per year. And N is just the total number of compounding periods, which is the equivalent to M times T. All right. And the second formula is the continuous compound interest formula. All right. So the number of compounding periods here for the first one is going to be finite. But if the number of compounding periods becomes infinite, then there's going to be a formula involving exponential function with e. So the amount after t years A is equal to P times e to the RT. Right? It's the formula. Right? So you can see that the difference here is here M is finite. Right? Continuous compound interest formula. So if the interest is compounded continuously, which means that the M is infinity, so interest is always continuously compounded, then we use this second formula, right? So this is our first formula, and then this is the second formula, right? So those are the compound interest formulas that we use. All right, that's it. I hope that this was clear.